And so it is. Welcome to functional programming. So this is the last of the paradigms that we're going to explore in the program. So believe it or not, you've done 2 of them already. You did OOP yesterday, and we've been doing OOP, a little bit in Mod 1, a little bit in Mod 2. There is another paradigm that you've done as well. Anybody know what it is? Starts with a P.
Prototype based.
Nope. Good guess.
Oh, wait, procedural?
Procedural. That's where we started with all of this. Procedural programming is you start at the top and you go to the bottom. You control flow through the program with function calls called, wait for it, procedures. And so we can store repeated behavior that way, but otherwise you just write some code. So things like Hashketball, for example. Hashketball was procedural programming. The Bachelor, procedural programming. We weren't organizing things in objects. We weren't really organizing things by functions either. Really just writing some code. So we call that procedural programming, which leaves us with these other 2, object-oriented and functional. I'll tell you right now, the biggest difference between functional and object-oriented programming is that if you think back to our first OOP chats, we talked about behavior and state. An object is a way to combine state and behavior. This is the state. These are the things that we can do with the state. Things that were outside of the objects, the only way they can get state is through methods. You call methods to change state, to read state, to do something with state. All of that stuff is all encapsulated together. That's OOP. In functional programming, we have an opposite approach. We want to separate state and behavior as much as possible. So we want to make these functions that describe behaviors that are agnostic to state and data. You could pass any kind of data into them and they work the same way every time. So 10,000 foot view, that's the big difference here, is we're trying to have as little state as possible in functional programming. So I want to start by having you guys do some research. We're going to do a little bit like show and tell style. So let's start with kind of quick, 4 minutes. I want you to research tenets of functional programming or functional programming principles or ideas in functional programming, something like that, and we're going to make a list together. 4 minutes, go. Let's see if we can make a great big list.
answering me when we're already here?
Oh, no one can hear me because I'm muted. Jesus, come on, man. So, Yulia, can you give me one of the things that you found?
Yes, I found immutability.
Immutability. I'm loving it. Blake, give me another one.
I was reading about like recursion and like the first class functions.
Cool. Cool. John, give me another one.
Type systems.
Cool. Mike De La Rosa, can you give me another one?
Referential transparency.
Oh, my favorite one. Lydia, you find another one?
Discipline state.
Discipline state. Greg, did you find another one?
Man, I just ran to the restroom and read your answer to my tech question. I don't even know what we're looking for, to be honest with you.
All right. Jordan, did you happen to find one?
I think other people said the ones that I was looking at.
Okay, that's fine. Ryan, so I'll throw this out to anyone. Did anybody find one that isn't on this list?
Pure functions.
Yeah, it's not pure functions, but
Pure functions. Love it. What else? Any other ones?
Higher order functions might go along with first class functions, but I don't know.
They are not the same thing. Different ideas. What else? Cool, that's a pretty good list. So let's do this. How many people I got in here? 13? 1, 2, 3, 4, 5, 6, 7, 8. Tell you what, let's do it this way. Yulia and Blake, I want you to look into immutability. John and Mike, if you could look into recursion. Lydia, if you could look into first class functions. Greg, if you could look into higher order functions. Jordan, if you want to check into type systems. Ryan, if you want to look at referential transparency. Nolan, if you want to look at discipline state. And then James, if you want to check out peer functions. I'd say James and Ashley, check out peer functions. And then you're going to teach all of us a little bit about it. Doesn't need. I'm here to help. So like, if something's wrong, I can throw you a life preserver. But little 1-minute presentations on what you found. So go for it. Let's take 5 minutes.
Are you going to put us in breakout rooms so we can like discuss?
No, you don't have to work together. You can if you want to. You can research independently also. That's fine. Mostly just trying to get an idea of what these vocab words mean. All right, pencils down, let's chat. Yulia, what did you find?
I found that the immutability can happen on two levels. Reference mutation, when you assign a new reference to an existing variable, and value mutation, when you modify an existing object. We cannot hear you.
Sorry. Very good. Somebody else had immutability too, right?
Yeah, it's me.
Cool. What else can you add to that? So
Um,
we had value reassignment and like object mutation. What other things did you find, Blake?
Basically, I was just reading the reasoning behind it. And it's
Mhm.
mostly towards like debugging and everything. So if you're changing states constantly and you have functions that do other things, you don't get the same result every single time. It's going to be very hard to debug. So that's kind of the whole concept behind immutability.
Exactly. And as Yulia said, this happened in a few different ways. We're talking about like reassignment. This is if I have a variable named A and I'm saying it's 3, if I reassign it to be 4 later, that's one kind of problem. Another problem is if I have like a hash or an object or something like that that has a property called name, and the name is Kyle at one point, and it's Elise at some point in the future, that's another kind of mutability issue. Mutability, we're talking about mutation. Something starts one way and it ends up another. Something being immutable means it can't change. And to Blake's point, when things can't change, they're easier to figure out because we don't have to worry about which version of something we're dealing with. If I say A equals 3, A equals 3, can't be anything else. Much easier to debug.
Is that really
Very nice.
the reason why like you don't mutate state in a lot of front-end frameworks?
Yes, that's exactly why.
I don't know.
Also makes things faster because you don't have to check to see if it changed. You know it didn't.
Interesting.
But yeah, immutability is the hotness right now. It's in everything. Everything in React is immutable. Everything in Vue is immutable.
If I'm using reactive Vue, that is technically functional programming. It's not OP, not that's
Not necessarily. Remember, functional programming is all of those things that we talked about. Immutability is one of them.
right.
Other questions about immutability? Cool. One more thing I'll say about immutability is, in general, functional programming borrows a lot more from math than object-oriented or procedural programming does. So the idea that we can make a variable that's a little container and it can be one thing at one point in time and be a different thing at a different point in time, that's not mathematical at all. That's called the von Neumann style of programming. And it's really common. Most languages support something like that. But if you think of this in terms of like math functions, like y equals mx plus b, if y is 3, y isn't something else at some later point in an equation, that wouldn't make any fucking sense. You're making statements of fact. You're saying that like, all right, well, y equals mx plus b is the function, and we pass this m and this x and this b in, we get the exact same y every time. It's a statement of equality, not like a temporary placeholder container that is currently holding this. That's a major difference between how functional programmers think about variables and how object-oriented procedural programmers do. Very good. John, what did you have?
I had recursion.
Recursion. What's recursion?
Recursion is the ability for a function to call itself.
Indeed. Mike De La Rosa, why would we ever want to do that?
You know, I'm kind of trying to figure it out. But essentially, it's used to break down large problems into smaller more readable ones, or at least eliminate some local side effects. But I'm not exactly sure what that means. I'm looking at examples, trying to figure it out, but it's not really cementing itself. Cool. Any insight on that, John?
There's some algorithms that lend themselves really well to recursive functionality. Like a really good example of one is building like a, what's that pyramid thing called? Of numbers. I don't remember, but there's certain
1 1 and 2 2s and 3 3s.
Yeah, the Figueroa's triangle. No, I don't know what it is. But anyways, there's certain math problems that lend themselves really well to doing recursive functionality, and if you work a few of them, they make sense. But they're really weird to think about at first.
They're very like brain bendy and weird to think about. Another thing that I would have you know about recursion, especially as relates to functional programming, loops. That's how you loop in functional programming. There's no for loops in a functional programming language. There's also no if statements. There's no those, we call them control structures. Those don't exist in functional programming. And a good way to think about this would be if you've ever done any spreadsheet programming before, if statements in there, they're not logic statements, they're function calls. It takes a condition, and if the condition is true, it does the second thing you pass in, and if it's false, it does the third thing that you pass in. So similar thing with loops. There's no for loops, there's no while loops. Instead, we can solve all of those same problems we would solve with those with recursion instead. Any problem that can be solved with a loop can also be solved with recursion.
When you're actually doing a functional programming language though, like let's say like Scala or something like that, are there like libraries that basically make it feel like you are using loops? And
ooh, what an interesting question. There's actually a feature that is much like that you use all the damn time. We've been doing it since day one of the program.
Just
just like for each, or
yeah, our applicatives. For each, find, map, reduce. Even if you need to do something just an arbitrary number of times. John, how did you do that yesterday?
Using like this thing called range, which when doing a for loop, you create an array that's the size, or like a for each or something like that. You create an array that's the size of the array that you want to work on. And for each element in that array, you do something. And when you do a range, each number is the index. So if I have like a range that's 3 long, it would be like 0, 1, 2 is like the numbers inside of that array. And you could use that index to go over each term of that and just transform it, do like a dot map or something like that. Or any
well, it's an array. We can do anything we can do with an array, like a map or a filter or whatever. And so if it's just an arbitrary length, functional programs have like a range helper that just generates an array of an arbitrary length. For everything else, like a collection of dogs or a collection of users or something like that, that's how we loop, is we use they're called applicatives. Map, filter, reduce, find, and there's more of them also.
So for each, or whenever you're running through each element of something, that is a recursive function?
It could be represented recursively, yeah.
Okay.
But like, the important thing about it is that it doesn't fucking matter how it's implemented. You don't worry about the implementation. You worry about how maps work, how for each works. Who gives a shit how it was implemented?
Okay. Interesting.
So what's the difference between recursion and iteration? Like, what's the relationship between those two? And are they the same thing?
They solve the same problem. They're not the same thing. They are 2 different solutions to the exact same problem. And they generally generate the same result.
Iteration has an I value or something equivalent to that you are mutating and changing its value.
Correct.
Whereas when you're doing the recursive way, you're just looking at each element inside of it. You're not looking at there's no value that's changing each time you update.
Well, it's going in. An iteration does things over and over again. Recursion does things inside of each other.
John, what always helped me is recursion's always defined in terms of itself.
Right.
So like, if you can't define it in terms of itself, it's probably iteration.
Yep. All right, so that is recursion. Lydia, what were you looking at?
First class functions.
Cool. What did you find out about first class functions?
So I was trying to like find some concrete like things that they did or what they were, because I was a little bit confused.
Okay.
So they can pass functions as arguments to other functions. They can return values as functions.
Yes.
And they allow functions to be stored in variables.
Yep. So the first two things are principles of higher order functions, but they're very closely related. The third thing is really like the core thing you need to know about a first class function. It's a function stored in a variable, which means that we can do everything else we can do with variables. We can, as Lydia said, pass it into functions. We can return it out of functions. Couldn't do that in Ruby. Ruby, you couldn't write a method and then save it in a variable and then pass that into another method. There's no real like equivalent thing to that. The closest we got were blocks. And there's a couple things that we can do with blocks that are sort of kind of like that. But this is Ruby trying to be flexible. This is Ruby going like, oh, there's this awesome functional idea of like maps, for example. Maps aren't an OOP idea. You can't really do that in most OOP languages. I think it was added into Java in like Java version 9 or something. So they're like, oh, but it'd be really cool if we had something that was kind of like that. And so they came up with blocks. But in JavaScript, much easier. We can just save a function in a variable and pass it in. Can you think of some examples where we've done that before?
Are the dot thens first class functions?
No, but the dot thens can use first class functions.
Okay, so like console log then.
Sort of. So like you could use it that way. Let's take an example. So if I did, actually, let me use like actual programming. That'll be easier. So if I was doing fetch some URL, you see how I could like have some URL in a variable? Maybe that's Pokemon or pokeapi.co/API/whatever the fuck. All right, so I can save that in a variable and then use that variable, okay? I could log the result that comes back like that by using console.log as a first class function. I could also write an inline function like that. All right, well, if that's just a function, can I just write it like a function? Takes in a response and it returns response.json. And now I can use that like a first class function there, because it's just a variable. Dot then takes in a function definition. Cool, that's a function definition. I can also write that like this, which is way more common in functional land. Oops. That's a first class function. Just saving it in a variable. Cool. And then, let's see, Greg, what did you have?
Higher order functions.
Cool. Very closely related to this. What did you find out about higher order functions?
Basically functions that input other functions or output other functions.
Or?
I'm sorry?
So they take functions in as arguments, they return functions, or?
Is it
both?
Gotcha.
That's also a higher order function, is if it does both of them.
Okay.
So what have you done that uses higher order functions?
Like map or filter, right? No.
Exactly. So map and filter take in functions that you want to apply to whatever the array is. So like if I have some array, okay, so that's taking in a function as an argument that I want to apply to each of those numbers. That's why it's called an applicative. So maybe that function is double, and it takes in a number and returns whatever that number is times 2. And so I use double as a first class function, and that function gets applied to every element in the array. That's an example of a first class function. What's another example of a first class function? We use them all the time, especially in mod 2 and 3. I guess more mod 3 than mod 2.
Event listeners?
Event listeners. Second argument to an event list, to add event listener, is the function that you want to fire whenever the event named in argument 1 happens. That's also a higher order function. One more thing. So something that returns a function. We haven't really had occasion to use this in the first 3 mods of this program. You'll use this a little bit in the 4th one, though. You'll get some outer function that takes in some outer value and then returns and does something that uses both of those. So you end up with some outer value times some inner value. And that ends up getting used like some outer function 3, 2, and it returns 6. That's an example of returning a function.
Is that currying?
That is currying.
Okay.
Good vocab. No functional person would write it like this, though. They'd write it with this shorthand. You're going to run into this at some point, and you're going to feel like an idiot because it's inscrutable. But they'll write it something like const A equals x, y, x times y. And then you would use it like A, 3, 2. This line and these 5 lines are identical. That's another thing that's really common in functional programming. It's terse as hell. Really, really short, tight, dense code.
Can you break down how that works possibly? Like, yeah.
So If you were passing this into like a dot then or something, you'd get what it does, right? It's a function that takes in y and multiply and returns x times y. Okay, so that's a function. Also, that's a function too. It takes in an x and then returns this. It's returning that function. Takes in an x and returns that first function. Again, it's the exact same code as this, just really way shorter.
Is the second one as readable for someone who is experienced with functional programming, or is it more readable even?
It can be more readable because, and this is really common in functional programming too, what we care about, and like even the shorter variable names are a little bit more forgivable in functional programming because we're describing a particular shape. Something that takes something in and returns a function that takes something else in and then combines them together. Like this example, probably doesn't matter that much. There's a lot of other things that make more sense as their abstract shape than any concrete version of that shape. If that hurts your head, don't worry too much about it. But that's what the other kind of higher order function is, something that's returning a function. We'll talk about it more in Mod 4. Something that takes a function in, we use them all the time. And as you might imagine, yes, you can do both of them at the same time in the same function. That's a higher order function. Don't worry about being able to use them or anything just yet. Just know that's what that word means. Yep.
So in outside of JavaScript and like C# or something, a higher order function would be like a delegate, right?
Yes.
Okay.
Correct.
Just making sure.
Awesome. Jordan, what'd you find?
Yeah, so I had type systems.
Yeah, what's a type system?
Well, my understanding is that like languages can be either strongly or weakly typed, or maybe it's like a spectrum. It's about how it enforces the types of variables that are being passed between functions. And so I think functional languages don't necessarily imply a certain typing system. Is that right? So they can be strongly or weakly typed. And there's something about how called type-directed programming that somehow defining the types helps you implement behaviors in some way. But
absolutely true. No, great summary. So Ruby is Ruby's strongly typed, but it's implicitly typed. Remember, like when we had integers, but if we wanted to do floating point math with them, we had to coerce them into being floats. It's because once something is typed, the type can't change. You can't start something, A can't start as a number and then end up as a string. We have to coerce it. That's strong typing. JavaScript doesn't give a shit. It's weakly typed. So you can change types of things all day long. This is frowned upon in both OOP and FP, it should be noted. It's not a functional specific thing. But functional programming does a lot of neat things with types, and type-driven development, which you were kind of hinting at, is the idea that if we first start by figuring out, all right, I write a function that takes in this type, and this type, and returns this type, I've really done like 80% of the work. All I need to do is figure out how to take those types and get that other type. And you can actually, they're called signatures. A signature is like, all right, this function takes in these types and returns this type. If you have that up front, like you can actually do a lot of other programming and then just fill in the implementation later. And there's a lot of like errors that you can catch before you even start an implementation just by saying, all right, do all these Lego pieces fit together correctly? That's type-driven development.
What's your favorite JavaScript superset like that's strongly typed?
TypeScript. So TypeScript is a superset of JavaScript. All JavaScript is legal TypeScript also, but it adds these strong types to it. And so you can do a lot more like cool functional stuff, because like the reason that type systems are powerful is A, they catch a lot of errors up front, and B, there's some algebra that we can do with types that we can't when we don't have a strong typing system. For example, if I have something that takes in something that's of type dog, it just needs to be a dog, and a dog is defined as something that can bark and has a name and has a collar. That's a dog. So if I take in a dog and another dog, then it produces a baby dog, something like that. What's cool about type systems is that if I have a Labrador is a dog, but a Labrador is also its own type. It's a subtype of the supertype. And so we can say, okay, well, a Labrador works for this function because it has dog somewhere in its supertype. You could also have a mutt. A mutt is just a generic dog. That also works. You'd have a generic dog and a Labrador and return some other kind of dog. That's how type systems work. That's like the mathiest, craziest shit in programming though. So if you want to learn more about that, it's called category theory. Otherwise, if you want to just ignore that for the first 10 years of your career, you'll be just fine. Cool. Ryan, what did you find?
So I had referential transparency.
My favorite one. What is it?
I think it was, so there was a super long one initially, but I think it was a little bit better expressed. So an expression in a program may be replaced by its value or anything having the same value without changing the result. There's a lot longer thing that I had, but I think that was a little bit more concise.
Beautiful. That is exactly what it is. Great explanation. Would you please read it again?
Yeah. An expression in a program may be replaced by its value or anything having the same value without changing the result.
Exactly. So in practice, here's what that looks like. In this one, you will get so much mileage up, especially as a JavaScript developer. So what this means is that 3 and some expression that equals 3 are identical. You can swap one out for the other and everything will work exactly the same. So that means I bring back my double function. And I want to use it, I can call double 3. I can also call double 1 plus 1 plus 1, and it's the exact same thing. I could also have some other function that returns 3 and call double 3 and invoke it. All 3 of these are exactly the same. That's referential transparency.
Is referential transparency something you want in an OOP language as well?
Not necessarily. OOP languages aren't always referentially transparent.
Like for example, in Ruby, you can't just put like a, well, that's a different thing. Never mind. You can't put like a function as like an argument for something.
Exactly.
Is part of that referential transparency that you can put that function there to represent that thing, or
yes.
Is it, okay?
That's exactly what that is.
That makes sense.
So this comes in really handy when we're refactoring code, because we can do things like go, okay, well, I have this really complicated thing, but if I can replace all of that with a function, now I can just call that function, and I didn't change the behavior of the program at all. I just cleaned it up. And in practice, you end up making these little abstractions that make your program a little bit more modular. That's referential transparency. Cool. Nolan, what did you have?
I had discipline state.
Cool. What's discipline state?
Okay, so I think it means that you avoid having a shared mutable state.
Mm-hmm.
So that the state is local, it's inside of a function.
Mm-hmm.
And it makes code more readable, scalable, and easier to debug.
Mm-hmm. So this is going to relate to pure functions, which we'll talk about in a sec. But what this is saying is that inside of a function, I can have variables. It's allowed. So maybe I have an increment function, and it's got an increment by 2 variable in here, and I take in some number and I return number plus increment by. Okay, that's discipline to state. Variables are state. Variables are state. Variables are state. Every time we're talking about state, we're talking about variables. That's a variable. That's state. But nothing outside of that function can see it. Nothing outside of that function can change it. Who gives a shit? That's discipline state. What we want to be careful of, shared mutable state, is if I have this outside here, all right, every time I call this, it's changing state that it doesn't own. So number plus equals by. Every time I call that, number isn't part of its state, and it changes it every time. And another function could exist called increment more. Both of those functions have access to the same state. It's a little fucked up. That's undisciplined state.
Is this one of those functional programming tenets that this is kind of like the opposite of OOP?
Yep, correct.
Okay.
OOP encourages this kind of thing.
Right.
Functional programming does not. Okay, very nice.
How do you avoid like global variables altogether with functional programming? Or?
Absolutely. That's like the cardinal sin.
Okay.
Cool, very nice. Toby, I don't think I gave you one. I came in a little bit late. James, what did you have?
Ashley and I had pure functions.
Excellent. Very closely related. What's a pure function?
Basically, it seems like it's a super simple function that, you know, as long as you give it the same argument, you get the same answer every time.
Mm-hmm.
It's been a little while since I did the reading. I kind of forget, but
it's an island to itself.
I like that. Island to itself.
No matter what happens, if you give it the same numbers or the same arguments, it will always, always, always give you the same result return.
Correct. So let's compare that with what we just had. If I do this, every time I call this, I change the state of the program. That's not pure. Pure, if I want to do this pure, would be what I had before. I pass in a number, and then I return that number plus increment by. So what this means is if I pass in 2, I get new number, which is 4. Every single time I do that, new number is always 4. Doesn't change at all. The behavior of the program is exactly the same. That makes it repeatable. That's nice.
It also said it's good for like testing your code.
Yeah, because having really stateful code is terrible for testing. Because now I need to make sure that the program is in the exact right state before I can test it. That gets really tricky, especially as your state gets more complicated. And if all I want to do is make sure that this logic is correct, if I don't have any state, all right, well, if I pass in 2 to increment, do I get 4? Cool, done, works.
So when you're talking about like OOP versus functional programming, is it more of like the way that you're coding? And I'm assuming that you usually don't code a project in an entirely functional way or in an entirely OP way usually, but there's sort of like guidelines. Is that the right way to think about it?
No, I'd say all 3 are valid. Pure OOP, pure FP, and like a mix and match approach, both of them are totally fine. I like mix and match. I think that's one of the most powerful things about JavaScript. You can't do functional programming in Ruby. You just can't. It's exhausting. Don't try. Python's the same way. They're not designed for that. JavaScript's a chameleon. You can do whatever. All right, and John, you wanted your functional versus OOP example?
Yeah, that'd be awesome.
So I have a class called like, I don't know, waiting room. And it has some state called like current number, and it initializes to 1. And then it's got an increment method that does this dot current number plus equals 1. And then I could make that a getter only. And so I make a dentist office is a new waiting room. And then I do dentist office dot increment every time like somebody comes up. This is like, I think, part of your pre-work or your entrance exam. You had like the deli counter thing. So if I was doing this with OOP, I'd probably do something kind of like that. Functional programming, I have an initial number. So I initialize it to 1. I have this increment function, which like that doesn't even need to know anything about my application. All it does is increment numbers. That's pretty easy. So then maybe I make a get next number function that takes in current number and an incrementer and returns incrementer current number. That's using like basically all of these techniques that we've talked about kind of at the same time. That's the same problem solved 2 different ways.
That makes sense. So like in the functional programming, rather than updating a state, you're just creating a new state.
Correct. Exactly.
And you still have like the same thing that sort of like I'm going to use the word state loosely, but like the state of your application is in like what's supposed to be what at a given time.
Exactly.
It's functionally happening in a different order or a different mechanism.
Exactly. You got it.
Okay, that makes sense.
Excellent. Jason, what did you have?
As in me?
Yeah.
I had dropped for a code challenge, but I had just done the I had done referential integrity.
Referential transparency. Cool. Austin, what you got?
I joined a little bit late. I didn't have anything.
Okay. So let's check our list.
Did anyone talk about immutability?
Yes.
Okay.
So we talked about immutability, recursion, first class, higher order, type systems, referential transparency, discipline state, and pure functions. All of these things at the same time, that's functional programming. At a high level, we're talking about splitting data apart from things that work on the data, separating state and behavior. So one of the ways that that looked.
Isn't recursion like more of a, like, isn't it apply to like any programming, not just functional, but like OOP or procedural as well?
It's a key part of functional programming because it's how you loop things without control structures.
Okay.
So if we're doing basically all of those techniques at the same time, our solutions look like these little independent abstract functions that we can combine together to solve our problems. You could also say that functional programming is a more mathematical approach to programming.
So
go ahead.
Can I ask a question about the functional programming side of things?
Yeah.
So let's say that like this were to represent like a web app or something like that, and then your like number of people was like the only thing rendering to your HTML or something like that. Or is it like, I guess I'm just a little confused on how you would control the firing of like events. Like, in other words, how would I update that on the page? In other words, at the end of my function, would I just call like, you know, some selector and then update it with the new number? I guess that's what you would do.
Okay, so the thing that we're missing is the idea of side effects. This is a side effect. It's not owned by this method.
Right.
But we're changing something that like that the method doesn't own. We call that a side effect. Anytime you have some variable outside of a function and we're changing it, that's a side effect. In functional programming, we're trying to minimize side effects. However, programs have to have side effects. Like a functional program that didn't have any side effects couldn't run because it would change the state from not running to running. Or like outputting something to the screen, that's a side effect. We have to have side effects at some point. However, what we're trying to do is be disciplined about when they happen. So one of the ideas is called pushing side effects to the end. So if we're transforming something, we do all of the transformations, and then if the side effect is that we show it on the screen, we wait until the very end to do that.
Would that carry over to like updating state in React? I don't want to.
Yes.
Okay.
Other questions? I don't expect that anybody is like a functional programmer now. I more want to give you some new vocabulary and hopefully some new eyes for when these ideas are being used. Functional programming isn't better than OOP. It's not worse. It's another tool. And it's usually for a different kind of thing. When I'm doing data transformations, like taking this array of objects and turning it into an object with these 50 arrays in it, anything that's like a transformation like that, functional programming is such a better tool. If I am modeling a bunch of nouns that verb each other, OOP is going to probably be a lot easier on your brain than trying to do that functionally. If it's teeny tiny, procedural programming, like don't get too crazy with it. You're writing a shell script, like neither the OOP and FP are way overkill for writing a shell script. Just write the fucking code. That's good for procedural. Cool, and thus ends your survey of programming paradigms. Any last questions before we break? All right, have fun.
I get different things out of this lesson each time.
Good, I'm glad. All right, cheers everybody.